Hi, greetings to you, sir. My name is PALCONIT, and I'm going to discuss about CISC and RISC architecture. But before we go start, let me introduce to you first the content of my discussion. First, introduce the RISC and CISC architecture. Second, the history of CISC and RISC architecture. Third, characteristic of CISC and RISC. Fourth, the difference between the CISC and RISC. And fifth, RISC and CISC advantages and disadvantages. So let's start. What is CISC? CISC stands for Complex Instruction Set of Computer. It is a type of microprocessor design. The CISC architecture contains a large set of computer instructions that range from very simple to very complex and specialized. So since it has already a large set of computer instruction, it takes time to execute the instructions. CISC approaches reducing the number of instructions on each program and ignoring the number of cycles per instruction. So it emphasizes the build complex instructions directly in the hardware because the hardware is always faster than the software. However, CISC chips are relatively slower as compared to RISC chips but use little instructions than RISC. In addition, what makes the CISC processor more complex is because it helps reduce program code by embedding multiple. When we say multiple, it has many operations on each program instruction. Next, what is RISC? RISC stands for Reduced Instruction Set of Computer. It is a type of microprocessor architecture that utilizes a small, highly optimized set of instructions rather than a more specialized set of instructions often found in other types of architecture. So, an RISC is an architecture design that executes computing tasks with the simplest instruction in the shortest amount of time possible. It is highly customized set of instruction used in portable devices due to the system reliability such as iPad, mobiles, and smartphones and Nintendo. In addition, it is built to minimize the instruction execution time by optimizing and limiting the number of instructions. It means each instruction cycles requires only one clock cycle and each cycle contains three parameters, which is the fetch, decode, and execute. So next, the history of CISC. CISC is based microprocessors found way into personal computers. The PCs evolved with generation after generation of CISC-based microprocessors being introduced to meet the ever-increasing demands of PC users. The microprocessor manufacturers began to refocus their CISC microprocessor design efforts away from general-purpose designs to a high-performance computing orientation. Next, the history of RISC. The first RISC projects came from IBM, Stanford, and UC Berkeley in the late 70s and early 80s. The IBM 801, Stanford MIPS, and Berkeley RIC 1 and 2. So all of this are the cycle of all of these are designed with a similar philosophy which has become known as RISC. And certain design features have been characteristics of most RISC processors. First, one cycle execution time. So this is due to the optimization of each instructions on the CPU and a technique called I.pipelining. Next is pipelining. So it is a technique that allows for simultaneous execution of parts or stages of instructions to more efficiently process instructions. And the third one is the large number of registers, or the RISC design philosophy generally incorporates a larger number of registers to prevent large amounts of interactions with memory. Next, the RISC architecture characteristics. So first, simple instructions are used in RISC architecture. Second, RISC helps and supports few simple data types and synthesize complex data types. Third, RISC utilizes simple addressing modes and fixed length instructions for pipelining. Fourth, RISC permits any registers to use in any content. Fifth, one cycle execution at a time. Sixth, the amount of work that a computer can perform is reduced by separating load and store instructions. CISC or RISC rather contains large number of registers in order to prevent various numbers of interaction with memory. Next is in RISC, pipelining is easy as the execution of all instructions will be done in a uniform interval of time. Example, one click. So as what I have said before that pipelining is one of the technique for the RISC. Next, in RISC, more RAM or random access memory is required to store assembly level instructions. Next, reduced instruction need a less number of transistors in RISC. And RISC uses Harvard memory model, means it is Harvard architecture. And lastly, a compiler is used to perform the conversion operation, means to convert a high-level language statement into the code of its form. Next, CISC architecture characteristics. So first, instruction decoding logic will be complex. Second, one instruction is required to support multiple addressing modes. So why is it multiple? It's because it is complex. And the third one is less chip space is enough for general purpose registers for the instructions that are operated directly on memory. And next is various CISC designs are set up two special registers for stack pointer, handling interruptions, and etc. And lastly, or fifth one, MUL is referred to as a complex instruction and requires the programmer for storing functions. Next, the difference between CISC and RISC. So the first one for the CISC is it emphasizes on hardware while the RISC emphasizes on software. Next for the CISC is includes multi-clock complex instructions, while for the RISC, single clock and reduced instruction only. And next for the CISC is memory to memory, load and store. And for the RISC is register to register, load and store. Next for the CISC is incorporated in instruction. And RISC is R-independent instructions. And for the CISC, small code size, highly cycle per second. While different from RISC, it has a low cycle per second and has a large code sizes. And lastly, for the CISC, transistors used for storing complex instructions, and while the RISC is spends more transistors on memory registers. So it is pretty obvious that they are very different from each other. And next, the advantages for CISC. So first, the compiler requires little effort to translate high-level programs or statement language into assembly or machine language in CISC processors. Second, the code length is quite short, which minimizes the memory requirement. Third, to store the instruction on each CISC, it requires very less RAM. Fourth, execution of a single instruction requires several low-level tasks. Fifth, CISC creates a process to manage power usage that adjusts clock speed and voltage. And sixth, or the last one, is it uses fewer instructions set to perform the same instructions as the RISC. Next is the disadvantages for CISC. First, CISC chips are slower than RISC chips to execute per execution cycle on each program. So as we all know that it stated in the difference between the two that RISC is more faster than the CISC. Second, the performance of the machine decreases due to the slowness of the clock speed. The third one is executing the pipeline in the CISC processor makes it complicated to use. But while in the RISC, it is the one of the technique that is very useful for the RISC. Fourth, the CISC chips requires more transistors as compared to RISC design. Last, or the fifth one, in CISC, it uses only 20% of existing instructions in a programming event. Next, advantages for RISC. So first, the RISC processor's performance is better due to the simple and limited number of the instruction. So since it's simple and limited, so it is really better than the CISC. Second, it requires several transistors that make it cheaper to design. Third, RISC allows the instructions to use free space on a microprocessor because of its simplicity. So, why it is used free space? It's because it uses a simple instruction. Fourth, or the final one, is the RISC processor is simpler than the CISC processor because of its simple and quick design, and it can complete its work in one clock cycle, while the CISC is the complex one. Next, disadvantages for RISC. First, the RISC processor's performance may vary according to the code executed because the subsequent instructions may depend on the previous instruction for their execution in a cycle. Second, programmers and compilers often use complex instructions. Why? Because there are different programmers. They use different methods. So that's why other programmers may use complex instructions that might be hard for the RISC to execute. Third, RISC processor requires very fast memory to save various instructions that require a large collections of cache memory to respond to the instruction in a short time. And next is for the summary. RISC and CISC are merely different design methodologies. So they're both a computer architecture, but they are very different from each other. Neither is inherently superior to other. And CISC architectures are equally capable of evolving the levels of performance being claimed by RISC. So the performance of microprocessor based in computer is function of more factors than just the microprocessor. So that's it for my discussion. Thank you so much for listening.